All right, so what we're going to start with in section 6.1 is we are going to talk in these first couple of examples about discrete probability distributions. So again, a discrete probability distribution is a probability distribution that shows the probability of each possible outcome when all outcomes are discrete variables. Right? Remember, discrete variables we just talked about are something that can be listed or counted. Discrete probability distributions can be represented as tables or graphs or equations, and we'll kind of see a couple of examples of both of these. Right, so this first one, this is a discrete probability distribution that is shown in a table and in a graph. Right, both of the images show the probability distribution for the number of stars given as a rating to a particular book on Amazon.com by a randomly selected customer. So the number of stars is limited to 1, 2, 3, 4, 5, and then using the number of ratings for each of these different ones, the probability from the whole was found for our probability here. And then what we see here is we see a probability distribution. We just see the kind of little vertical lines with dots. So 1 star, 0.02. So there's our first one. 2 stars, 0.03. 3 stars, 0.10. 4 stars, 0.23. 5 stars, 0.62. So our information that is in this table is also represented in this graph. Right, there is another way that we can possibly also visualize distributions. We can think about them as equations. So the discrete probability distribution can also be equations or formulas. The image shows the probability distribution of flipping a coin and every toss landing heads up. It can be written as 1/2 to the x power. And we'll kind of explain here where that formula comes from. All right, so our probability of tossing just one coin and it landing heads, right, is going to be 1 out of 2. Right, that 1 out of 2, if we write that in exponential form, right, that is 1/2 to the first power. We have exactly one factor of 1/2. Right, our probability of flipping a coin and the 2 tosses land heads up, well, that's going to be 1 out of 2 times 1 out of 2, using our multiplication rule from the last chapter since we have independent events. Right? If we write that using exponential notation, we have 1/2 squared. Our probability of 3 heads, 1/2 times 1/2 times 1/2, right, which gives us an exponential notation 1/2 to the third power. Right, so each different time we add a flip of our coin, we're adding 1 to our exponent. Our exponent is the number of flips that we have. So if we think about these in probabilities, 1/2, right, is 0.5. So the number of times that we toss one coin, it would be right here, that has a probability of 0.5. 1/2 squared is 1/2 times 1/2, which gives us a fourth, or 0.25. So 2 flips goes up to 0.25. 1/2 cubed gives us 1/8, which is 0.125. So 3 flips, 0.125. Then we would have 4 for the next one, so on and so forth. So these correspond to these values correspond to this formula. Right? So when we're thinking about discrete probability distributions, we may see some sort of combination of formulas, tables, and or graphs.